Hello everyone, my name is Batran. I'm the one in the middle. So originally Kyle was supposed to join us, but he have missed a meeting today. So the title of the presentation we have is a Geospatial Science for Retail at Rakuten. And we're actually going to talk about retail and also going to talk about last mile delivery and the case for logistics. So this is agenda we have. The first is introducing Rakuten, and the second introducing some of geo efforts we do at Rakuten. And then we will talk about people flow and catchment, and then we have some work to show on the logistics side. So it's a bit on the technical aspect of things. So Rakuten is a highly diverse and global company. In fact, it spans across a lot of places in the world, and it's in 30 plus countries, over 20K of employees, in 70 plus nationalities. And there are lots of companies such as Rakuten Bank and also Rakuten Viber and so on. So me and Yanyan, we belong to the Global Data Supervisory Department. So we are in a place where we receive data from lots of companies, and we handle those data in a way that makes some business insight and extract some knowledge to help drive the business growth. So we are both data scientists, and we usually work on the science and the modeling part. So this is Ecosystem. The group itself has e-commerce companies, payment companies, banking, securities, insurance, sports, and digital and life and insurance content. So all data is, of course, centralized, and we handle this data across multiple platforms. And there is a very strong geo aspect associated with lots of coming data. So we're going to talk about two of the use cases in this presentation. All right, so the first part is an offline behavior and preference. And this will be my part. So I'm going to talk about the improved inflow and user experience. And the next part will be about the last mile delivery and the case for logistics. And this part will be about improving package delivery efficiency. And this will be introduced by Yanyan. All right, so let me jump into one of the use cases for the geolocation contribution into the retail industry. And as you know, the gap between the online and offline retail is still really wide. 93% of the offline, the B2C sales are happening on still on the stores themselves. Now this is 2019's data. I'm pretty sure like COVID-19 have made a lot of like changes to those numbers, but there is still a big gap. And while the online platforms such as e-commerce have become pretty really good in capturing customer behavior and understanding exactly what the customer is, so that they can efficiently tailor customer experience and come up with a very a delightful experience for the customer that work online. So on the other side of the world, the offline stores, they don't have that much data about the customer visiting, and thus it's a bit challenging to really adopt the business and try to come up with new offerings to accommodate the customer and try to create a good customer experience. So we try to look at the data we have, offline data, explicitly the GPS location data, in order to capture offline behavior and try to aggregate this data to extract customer insights. Now, this slide is very good representation of what exactly do we mean by the geolocation data. Usually, when we look at the GPS location data, there is no way to get some insights from that unless you put it with context data. So from science perspective, we are always accommodating a lot of context. And the best context ever is a background map. When we display location data, we usually put that behind the background map. And just by looking at the sequence of locations on the map, it's pretty easy to just visually look at the data and try to extract some insight. And those insights can be the common route the user or the kind of customer usually take to arrive to your location. And sometimes this can be the origin destination data. Where is the origin of your visitor is coming from? And common like the transportation route and the frequently visited places, and also things such as the route and at-home time and interests and so on. Now this data is quite important when it gets aggregated. So it would be quite important to know how many of your customers come from this specific place or come from that specific place. So for a business, getting to know, for example, how many of their customers come to their place by car, it's it would be really beneficial to, for example, offer a discount on the parking place. And that will give them some competitive advantage. And also it will benefit the customer from getting a really good tailored experience using the data. So those are the common science models that we work with. Usually we do like frequent visited places, transportation mode, origin destination, routing, at home time, at work time, and interests. And of course, all this is going to be aggregated before it comes outside of the algorithm, and it's going to offer an aggregated insights from this analytics. All right, so this is a typical use case for it's a bit technical on the technical aspect. And this is an actual trace. And this trace, of course, is not of a user. It's from a Rakuten delivery vehicle. So we are tracking also for logistics, the vehicle themselves, when the driver is making a delivery. And as you can see, when we receive those types of points and we lay them over a map, when there is a delivery or when there is a stop, usually we get a lot of points. And those points are in the exact same location, but in different timestamps. So the first thing we do is laying all those data in a map, and then we jump into a clustering part. And usually we use SD, like spatial temporal clustering, in order to capture the clusters. And the clusters, it's a common general analysis, ST scan or spatial temporal scan, to extract the amount of points that are in the exact same location or close to each other within a threshold. Once we extract those clusters, we connect those clusters together in order to capture what's called an origin destination. And this is industry-wide, this is quite common to do that, to extract a trip. And a trip is always like a start and an end. And between the start and an end, you get a lot of context and information. So that context may be, say, for example, transportation mode. And here plays a lot of work on the modeling and the machine learning and so on. But at the end of it, this is a base of representing a trip, an origin latitude. This is a longitude, an origin latitude, and then origin time, and then the destination longitude and destination latitude and destination time. So once we estimate those origin destination data, we try to enrich that with lots of attributes, such as the purpose of the trip, for example, also the transportation mode, and so on. And then this data gets aggregated in order to produce an insight for a specific business. Now, let me show you how the aggregation works in one of the use cases for offline businesses. If we look at the target area, assuming this place is an area of interest, and say this is a business, an offline business, and that offline business actually wants to understand where people come from and get to know more about the visitor's behavior. So in this scenario, once we understand the origin destination data, it's quite doable to aggregate those data to come up with an insight that, for example, 5% of your users are coming from this specific location, but only 1% of your users are coming from a specific location. So the target area here is an imaginary, but this is how the analysis are happening. And based on that, businesses can adjust to their, for example, like offerings, try to offer better customer experience and so on. At the same time, if we look at the macro scale, so this is on the micro scale, looking very close to the business themselves. But if we look at the macro scale and we look at some bigger areas, it's also possible to know on the macro scale, where are the visitors coming from in other cities, for example. So for an area or for a park or for an offline business, to know that, for example, like 10% of your users coming from a very specific location, such in this case, for example, a lot of users come not only from, or a lot of visitors not only coming from the neighboring places, but also there are two very distinctive areas that attract a lot of visitors. So that might be very interesting to know, and also to look into the reasons and try to adjust. Perhaps opening a store or a branch in this location or in this location may actually give the customer, a delightful experience, so you don't have to commute all the way to go to your branch and so on. So as I mentioned one or two times, we always aggregate data. So all data is aggregated, and we try not to do a lot of consulting work, as we don't do that case by case, but we also try to do that as in form of products. And an ideal product coming out of this is an API. So from the engineering perspective, we do lots of APIs, and typical API is a post API, where the input would be an area of interest, for example. That would be a polygon. And then the response would be something around how many people are coming to your area from this specific location. And there are lots of changes that we can do here on the granularity level. So that could be a city, that could be a prefecture, and the design itself is up to us. It's quite easy to change the design. But that's trying to emphasize that the output of those analyses is usually an API, and it gets connected to either a platform or, for example, sometimes connected to another data science that is doing some work in order to create some presentations to add some business value. Now, the previous one was only on the origin destination, but some of the work we do also involve getting to know how long the customer is willing to actually walk to your store. And again, in terms of geolocation data analysis, this is usually done using the ISO lines or Isochrome, whichever you call it. And if you're not familiar with ISO lines or isochrones are how far, it's kind of like a control line if you are coming from a geomatics background. And let me play this video to explain what exactly it is. Assuming this is a store, it's exactly on the GPS location, this location point, and I'm going to play the video, and every step of that video is 1 minute. And when those lines starting to go out, this is how far a user or a person will be able to walk in any direction in 1 single minute. So let me play the video. As you see, 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, 6 minutes, and every minute we try to do the analysis in order to say, in this amount of minutes, this is how far any person can go on an average walking speed in this direction, or in that direction, or in this direction, and so on. Now, obviously, by doing that, there is a benefit of being able to draw some sort of polygon around the areas with the exact same time. So if we come, for example, like 5 minutes, we can say this is a polygon for 5 minutes. And then try to understand the customer behavior or the visitor's behavior in accordance to that very specific definition, which is Isochrome. It's quite useful to actually use on the analytics side. So moving to the next one, this is what I was mentioning about the Isochrome. So the previous one was an ISO line, and these are the lines. And when we try to connect the polygons, those becomes the polygons themselves, which is an actually isochrones. So the target area, say the CN1 is the target area, where we are interested to know the kind of catchment area or the visitors. And the blue lines are origin of trips for a specific time, say for an hour, for example. So this is where your user come to your shop or to your location or your area of interest, and those polygons represent isochrones. And by looking at that, it's quite easy to draw some conclusions that can help the businesses understand the behavior of their visitors, such as you can say that X amount of visitors are willing to go to your store from, say, within 10 minutes. But if it's a bit far from that, that number becomes, let's say, 5%. And going far, that number becomes like that much percent, and so on. So talking from this perspective, it's quite easy to draw some conclusions that can help actual business operators. Now, we don't only look at the catchment area itself. It's important to map the catchment to actually know the catchment of the store, but it's also as equally important to understand the underlying population distribution in the area of your catchment. Obviously, if most of your visitors are coming from this specific area, you would want to know what type of people are living there, and what is the demographic distribution of the people that are living there. And as Maria mentioned in the previous presentation, that you use a lot of publicly available data in Japan as well. And I think in a lot of places, the publicly available demographics data and statistics can be accessed and can be cleared. and be processed in any type of database to generate some like aggregated insights. So we also do that in so looking more at the catchment area. Oh, I actually forgot to remove that comment. But the main point here is giving the an actual polygon, and that polygon can be, for example, the catchment area itself. When we look at that catchment area, we can also draw the same conclusion we did in the past for the exact store itself, such as for the people that are visiting this specific area, where are they coming from? Generally speaking, for that area, where are people actually are trying to inflow or like inflowing from which area and so on. At the same time, looking at the population data and demographic data, and try to represent the people that are living in this area or the demographics of this area. And we look at that using this chart. This is a very common chart of representing the demographics distribution. The orange one is female, and the blue one is male. And y-axis is the age group, so 0 to 1, 1 to 5, 5 to 10, and so on. And the x-axis is the population count. And by looking at that, it's quite easy to understand when you map your catchment area, what type of people living in this catchment area and so on. So again, we try to do that again as an API from the kind of data science perspective. So the science itself will go and wrapped around an API where you send in a polygon and we send back some sort of like aggregated demographics or aggregated origin destination data and so on. So that was the end of my part, walking through some of the catchment area and people flow. And in the next part, Yanyan would be presenting about the e-retail and logistics and trying to introduce some of Rakuten's effort in the e-commerce and the last mile delivery. So Yanyan, over to you.
Thanks, Batran. Hi, everyone. My name is Yanyan from Rakuten, Japan. And today I will give you a brief introduction of the Rakuten's logistics business. And in Rakuten, we have 3 types of delivery services. The earliest one is Rakuten Express, which started from 2016. Rakuten Express is mainly responsible for delivering groceries, clothes, books, and some small electrical devices. But due to the 2 major social issues, the population aging and frequent nature disaster in Japan, Rakuten also actively developing new logistics services. In 2016 also, we started testing the UAV, unmanned aerial vehicle, which is extremely useful in delivering goods from island to island and delivering emergency goods when the nature disaster occurred. Also, we have UGV, unmanned ground vehicle, started from 2020, which is used for delivering grocery from supermarket to the nearby area. But given the size of the business, we will put our focus on the solution for our express today. Next slide, please. And Rakuten provides services for the whole product journey, which is from the merchants to the customer. The last mile delivery is the final step of the process, which is the most expensive and time-consuming part. But our goal is to provide a science solution to improve the operational efficiency, thus to reduce the overall cost and improve the customer satisfaction. Next slide, please. So far, we have developed 4 products to empower the last mile delivery. When the goods arrive in depots, they need to be sorted and distributed to the drivers. We have built dispatching for that purpose, aiming to reduce the total delivery costs and improve the efficiency. After that, we have the geotracing to check and visualize the driver location in real time. For the customer part, we also develop ETA model estimating arriving time to give prediction for the arriving time of goods. We expecting this function could help reducing the redelivery rate as well as increasing customer satisfaction. Combining the multi-data source that we collect from those products, we are able to provide insight to stakeholders about the performance from the macro level, the whole last mile business, to the micro level, in the individual driver performance level. And I will give you more detail about those four services in the next part. And next, please. As I have mentioned above, dispatching is to allocate packages to appropriate drivers with delivery sequence in order to minimize the total cost. We provided two types of dispatching services. One is the depot-level fleet dispatching to arrange the package for all drivers in the depot. We also build deep learning models to capture the driver's experience and geographic information to better optimize the routes. The other one is dynamic routing. In case there is any change in the delivery sequence, for example, when the customer cancel the delivery or they want to change the time window, we also provide a fast rerouting function by which the driver can get the new sequence of the package to deliver. Next, please. Our second product is geotracing. By the driver management system, the depot manager are able to check, for example, where the driver acts now, whether this driver is following the recommended route or not. Is the driver driving or doing something unexpected? And geotracing also provides the hourly-based driver productivity index to illustrate the workload distribution in that day. After 1 day's work, we also provide the overall performance report for that driver X to help the depot manager to better evaluate their drivers. Next, please. And the third product is ETA. ETA was designed to benefit both customer and logistic management people. We also provide two types of ETA solutions for Rakuten Last Mile. The static ETA is calculated by the dispatching, which gives a rough estimation of the arriving time before delivering starts. Customers can use it to better plan their date rather than sitting at home and waiting for the package. Another one is dynamic ETA, which is to calculate the arriving time based on the actual driver location, together with the time in that day and the traffic condition and the delivery data and so on. The information keep updating along with the change of driver's location and the package delivers data. When the driver is near the customer's location, we could use the ETA to inform the customer and they can prepare to pick up the delivery goods. The depot manager also can use this information to adjust the delivery plans also. Next, please. So the final one, the KPI monitoring. With this tool, all the information will be gathered and organized. We can generate in the customized daily-based science KPIs and business KPI to help the business people better understanding the situation and making their business decisions. Next, please. That's all for our presentation today, and thank you for listening.
Great. So thank you, Yanyan. And I think that's all from our side. And if you guys have any questions, we would love to have them.
Yeah, thank you very much, Batran and Yanyan. It was a really interesting presentation covering a lot of use cases there. I do have a quick question for you. How many people in total in the data science team at Rakuten would you say have expertise in the spatial side of things?
Right. I think that's quite challenging to answer. So we have lots of teams that are working in geolocation data. So our group may be around 15 people, but there are 15 people more working on different geolocation aspects. And there are more, I think if I'm trying to give an estimate, that would be about 50 people or something.
Mm-hmm. And typically, when you go back to like a business area, operations, supply chain, how do you typically present the results of the spatial models that you create to them?
A lot of challenge. That's always challenging. You know, the process of discussing with businesses between science and business is always a challenge. trying to present science work and try to get value from that. But typically speaking, we start by POC, and in the beginning, this is sort of consulting work. So we do the visualization analysis, and we try to invest a lot on the product development part, and that's usually a presentation type of. And our work is one of three things. One is, as I mentioned, as a presentation that could be an output. Another is a dashboard that can be dynamically updated, such as, for example, driver productivity. That can be a dashboard, Tableau or Power BI or something like that. And number three is another data set. So we take data sets and we try to analyze it, and then we try to get the insights and put it in another database for someone else to use it. And the last one is a model, which would be like a machine learning model or a deep learning model that would be used by another business and so on. So if we talk about businesses, usually it's either for example, a PowerPoint or ideally a dashboard that gets updated daily.
Fantastic. Great. Well, thank you so much.